So I guess initially I wanted to get around doing exactly what I've prototyped last night. Well, yeah, because it will definitely be a huge mess and moreover also may become a bit dangerous. Because today, and this is the mess part, we're gonna use these CNC spray mist cooling devices. Yeah, to put a lot more of water on our benchy print to see how far we can push cooling results. I'm gonna use 2 of these. We're gonna start with water, and if I haven't messed anything up really bad, we're gonna do the same with ethanol. Okay, so the way this works, basically you got this block with 2 fittings attached to it. One of them gets air inside and it's gonna be like just pushing that out of that hose. Right here in front of it is the magic part, which is sitting very close, and actually for the price being, this is very well designed. So basically we got a Venturi adapter right here that is gonna create suction through another hose that is going up here. And this is gonna suck in water. If you follow that, I got a small little tank. This is just filled with some water for right now. I wanted to get it away from everything that is moving, where I can like tip it over away from electronics. And I don't really know how good you will be able to see that, but the plumbing, I got an air hose that is teed off to one of those inlets. Those inlets are all the way screwed out, so they have no resistance here. And both of these are hooked up to the same pressure regulator, so I can have one control for both of these. And now I'm gonna go ahead and just open the valve here. The amount of water you just saw is very low. This was 1 bar of shop air pressure, and there is like a quarter turn of the regulating side of the pickup for water in this system. I could pretty much, if I gave it everything, I could fill this tray in a matter of a minute, I guess. This will be like 100, 150 milliliters. So I guess I'm gonna find a setting somewhere like this, where I can spray the whole print, but especially right below the nozzle. See if this somewhat holds up in terms of the PID control, start with a low volume, and just try to see if we can print a benchy. Let me try to set that up.
Da 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 da.
It looks like the benchy is going through a car wash. But the first good news is PID control of that, the upper one is it, doesn't seem to be too bothered, at least not in this configuration. Got very low airstream. If I increase it to, this is half a bar, let's make it 1 bar. Oh my. But again, it might work. It might work. All this talking, has anyone noticed yet? So this is the second time this actually happens on the machine, because of this weird Z-axis thing I've built here. This doesn't move with the Z-axis. Everything else is homed, warm, filament is loaded. It just dawned on me now. Let me try to come up with something else. And just if you've missed it, my name is Jan. I build stuff so you don't have to. This hot end did look ridiculous before I started adding another stuff to it. But yeah, after my first encounter with it, I basically just found this spot. Seems to be a very good fit. I just put a wooden screw in here, basically on both sides. And yeah, this maybe is the better solution to start with. Again, I have put it in basically the same orientation. Since the benchy is sitting at a 45-degree angle, I want to have one that's spraying to the front of the boat and one to the back. And they are basically like 50 millimeters spaced apart. So I'm covering the whole print. I think I have everything set up. Let me just push go and see if I can get any of this on video. This is what we got, first try. And yeah, right here where the separation begins, so you can see layer adhesion was not working anymore. But I was at reference speed, benchy, 3 minutes 20, to compare it to all the other results. Have a look here at the overhang. I mean, layer adhesion is not good here, but also this is basically a very thin wall. Two things I want to do for the next print. I got 1 bar of shop air to it. It seems like you need basically a base amount of airflow to get finer droplets from the mist side of things. So I think I'm gonna leave it at 1 bar, but up the temperature here from, we're at 210 now. I'm gonna go right away to 240 or something. Let's see if we can make those layers stick. And also I have no idea if the next one will stick to the print bed and how long my air bearing is gonna hold up. But this is somewhat interesting to see. So this is the back. Nothing too fancy. We printed a lot of sexy backs here. But have a look at the front. This is reference speed, 3 minutes 20. Take away everything we can do in input shaping, etc. This is sublime. This is the best cooled benchy front I've ever seen here. I mean, sub 6 or 7 minutes or something, but this is a 3 minute 20 benchy, and there is literally nothing to be seen that these overhangs wouldn't work. And these overhangs are quite steep. This is like at least 45, more like 60% right here at the bottom. And right here at that little notch, I gave it the reference speed. Everything down here is just to make it stick. These bottom surfaces look nice. Infill is there. I've seen a lot of prints where infill is just not deposited anywhere, it's just blobs inside. Stringing is low, so this looks really promising. Biggest problem so far, bad adhesion. So for every application of the masking tape and glue stick, I get 1 good print with adding water on top. That's at least my experience. I can reapply the glue, but you see the result. Whew. So again, this was at 240 degrees. I'm gonna rerun the same exact thing with fresh masking tape, and hopefully we get a finished print we can have an overall look on. Let's do that. I'm hyped. Alright, maybe you saw the video on the other camera. This one did not finish. I got some error on the PID control again. So what happened? I was investigating a bit, and apparently when I screwed the back one in, the second mist cooling thing, I closed the valve all the way, so only the front one was working. That's why we only have spray here in the back, and also front was looking the best from the print. So now I have both of these adjusted again, so there is an equal amount, and the PID control, you can see it here basically. In a very short time the extruder one did drop significantly and gave me out PID control. So I'm gonna put new masking tape on, then close the back one, run just the front one with same settings again, and yeah, see if we can finish a benchy. So this is my catalog so far. Right now, cooling is not my main issue anymore. It has become bad adhesion. So apparently spraying that amount of water down there somehow penetrates between the first layer and the glue stick. But again, this has been one of the longest ongoing prints. And again, this is looking pretty damn fine if you just have a look at what I got on hands. So brute force doesn't work, but I have no real other options. I want to see a finished benchy, so what I'm gonna do now is go into slicing again and print it with a giant brim. Maybe this will hold up the water. So a brim without any like small little gap. What we're interested in is how everything above looks. Yeah, so starting here, as you can see, a lot of moisture made its way down to the air bearing, but it was holding up. Yeah, this is it. This is the benchy. So at least the brim workaround did work. I haven't done anything else to the print. This is again 3 minutes 20 reference speed. So again, this filament is working great. This is high-speed PLA by Fiberlogy from Poland. What it is not good at is making it easy to judge. Something matte with more contrast is working better. But you can see here in the light's reflection that the front surface of the boat is looking really decent. Just the slightest amount where the overhangs didn't catch, but it's just the way outer lip. The overhangs do look really good. They haven't sagged in like in all the other attempts with various cooling methods. Also here. Chimney does look decent. I mean, it certainly does look a bit better from the front than from the back. But then our main takeaway here has got to be this section from here to here. So basically we can see that I guess temperature from the extruded material has gotten too low when it was being brought up here. And this somewhat makes sense, because it's doing very small movements and then it has to cross open field, which is not the case at most other places here on the Banshee. This is the first Banshee I got in its full glory, and took me like 3 hours to do that, because after each print I have to reapply the glue stick, etc. So for this kind of approach I would need a different solution in terms of sticking the Banshee down to the build plate. Otherwise we're not gonna get enough data points to make quick iterations here. Top surfaces do suffer the same effect than this here. As you can see, a lot of moisture made its way down to the air bearing. It is probably handling it kind of fine. The moisture will certainly not do anything to the granite. Air bearings don't like it though. There will be additional friction at those bearing points, and of course I have to see that this is not spraying there in my electronics and on the motors, etc. But this is kind of contained, so I'm okay with that for now. I'm gonna disassemble everything, clean it up and let it dry overnight, since this is my last attempt for today. Yummy! Yeah, so welcome back. It's the next morning. I already cleaned everything, and before we go into detail what this is, let's have a quick chat about today's video sponsor, which is PCBWay. So if you have seen these videos, you know that they have been contributing to the project for quite some time, and I use their service on a regular basis. For those that haven't heard, PCBWay is an online service where you can get parts, essentially, in various kinds of processes, like 3D printing, CNC machining, PCB design and production, sheet metal, injection molding, basically you name it, they got everything. All you have to do, go to their website, upload your files in whatever formats you have on hand, and if it's a straightforward part, you basically get an instant quote and a lead time on when they would ship it. If it's more like a complicated part, basically an engineer will contact you and ask you about wall thickness, etc. And I've been enjoying these conversations quite a lot, because you're not chatting with a bot or something. So if you're in need of any part for your project, go down in the video description. There is a link to their website where you get a discount on your first order. So again, PCBWay, thank you so much for your help on this project. Let's get along with 3D printing. So my plan for this video was to not make it too long, basically just have it as an addendum to everything we did beforehand in terms of cooling. But this seems to be like a very interesting approach, and I want to investigate a bit further. So main problem is I would need a lot more testing to give you a solid answer on if this is what we're looking for. But bad adhesion is like the problem I face. And even if I would have a heated bed with state-of-the-art PI coating or something like that, we probably would run into the same issues, because this has so much cooling potential that also a bed surface will be blown cold in a matter of seconds, and it would surely lift off. So that's why I printed these overnight. These are PETG, basically just round discs, which I then glued with double-sided adhesive tape to my print bed. So the theory behind this is a lot of people use PETG as an easy alternative to support structures in their PLA prints with AMS, etc. So the way this works, PETG and PLA does form a bond by themselves when being applied on top of each other, but you can consider it as not permanent. So I hope this will give it enough stick down force to make it throughout the print, but then I'll be able to release it. Let's see if that works. We're gonna start with a slow print for 4.5 minutes or something, and I have disconnected the water hoses. Oh. So we just have normal top air strength. I was kind of hyped. That worked out pretty good from the start. And as you can see, this is a pretty decent first layer. Kind of squished down, but this is exactly what we wanted here. I had it on camera when it loosened up, so I'm gonna rerun this with some glue stick applied, see what this looks like. I mean, compared to the masking tape, this is a lot easier to just swap out. I have a few of these on hand and I can just hop swap them. Okay, let's see what bad adhesion looks like. Actually pretty good. The adhesive tape below seems to be the bottleneck, but it has way more surface area, so maybe we get away with it. Okay, yesterday we printed this one with water applied through the mist cooling system, and I had the theory that we do have too much cooling here in this area, especially like these blobs and boogers and stringing occurred. So then this is the first print that has lifted, and I noticed the same pattern here. And the next one that has finished looks like this. And to test my theory, throughout the whole print I had 1 bar of cooling pressure on the system, and right here when the bullnose finished I ramped it down to half a bar. And then in comparison, this seems to be the worst in terms of stringing, etc. So what this basically tells me is we need more. I'm gonna try to replicate this one on this print bed. Hopefully it sticks to the end. We're gonna print another brim. I'm gonna go 1 bar because this seems to be sufficient throughout the print. And then here I'm gonna go 1.5 or something. Let's see if we can get an improvement here. Let's have a look at what we got here. So it's a complete print, and I don't know what has really changed, but the outer appearance doesn't look quite as crisp as the last one, but still kind of impressive for the speed we're running here. So all this fuzziness away, this is actually a pretty decent Banshee, and it isn't on tape. But have a look at all those overhangs here. These look sharp as fuck. And the first like bridging layer here for the bottom surface of the roof, it was like completely flat, not dented in as with all the other approaches where we have like a lot of air moving downwards. So one thing I did notice is the very first print we did, I think it's this here, we were printing at 2010. We had instant layer separation here, so the filament wasn't warm enough. And this has been my usual go-to printing temperature. I did notice that once I bumped up temperatures by 30 degrees with this material, it got so much more runny that usually I do an extrusion first, so basically prime the hot end and then start the print. There is a bit of oozing happening, but not too much. In this case, I have to really shut the nozzle close, and there is so much back pressure just by the filament wanting to get out of here. So, and I guess in especially these upper parts, we have a very few milliseconds only moving from one pillar to the other, but it seems to be enough that filament is oozing out of there and creates this stringing. So I want to reprint this and go down again, somewhere in the middle, let's say 225, see if that makes a difference up here. In this particular print, this is 1 bar up here, and then for this section I upped it to 1.5. Let's do this as probably last test for this video, go 225 degrees C and then draw a conclusion. To 40 to 25. You can see on the outer walls this seems to be a bit better, but then in terms of stringing it did not, and we have to think about if a single print does tell the whole story. So I think they look pretty similar after all. I got one last plug available and already installed on the machine. As with all of my testings, my methodology behind it is always to make a ballpark assumption and see if it makes kind of a difference, see what we can derive from that. With this print being 15 degrees lower, that wasn't the case. Let's go higher. This was 240, let's go 260 or something. See if that makes kind of a difference that is noticeable. This is not an extrusion move, this is basically oozing. See what I'm talking about? It really has the tendency to make its way out of the nozzle. This is 260 by the way. Yeah, so you don't need to be Uri Geller to know that 260 was too much. I have no idea how much of that is on tape, but you could see how runny it was, etc. So yeah, we were in the right ballpark, somewhere between, let's say, 215 to 20-ish to 240 maybe does work on that filament. It is basically exactly the range that is on the spool itself, but not higher than that in PLA. Let's go over to the bench and draw a conclusion. Starting out with the obvious downsides of today's testing with spray mist cooling. So first and foremost, you saw my struggle with the bed adhesion. That is a problem and will be a problem because we're in 2025 and we have teleported ourselves back to 2013, where bed adhesion was one of the most common problems in 3D printing. And now we're back at it again. Even with state-of-the-art PEI-coated magnetic sheets or something, this won't work. Any of them does need a certain amount of heat in it, and even if it's just 35 degrees or something. These won't stick because all of these sheets are designed to release the part in a cool state, and spraying water on it certainly doesn't help. On top of that, it's a huge mess on the machine. In my particular case of the air bearing, it held up, it seems to work. On any other machine it would probably be a even more mess because I have a lot of open space here on the machine. There is the contamination area is kind of this big. So I get away with it, but in your everyday 3D printer, just imagine that kind of mess that would be created in a chamber. That is out of the question. We need some solid engineering to make that work on the long run. And also we face some problems with stringing, which we kind of solved in the past, but somehow have to go higher in temperatures, which brings stringing back. If you use the same temperatures as we do with standard air cooling, yeah, then layer adhesion becomes a problem. Now, the upsides. So layer adhesion, I can't really test that here scientifically, but it doesn't show any problems of being weak. I already contemplated giving Stefan from CNC Kitchen a call if he would be able to test that scientifically. But then again, I don't have the print size, area and height to print standard specimen for that. Maybe we'll do that in the future, but not in the current iteration. In terms of just setting this up, it's a pretty easy setup. I just mounted it somewhere, you saw that in the beginning. The whole unit is a laughable $25 and it works out of the gate. I was being prepared to throwing a lot of cooling at my nozzle situation. That's why I have been planning this for, let's say, a month, to have proper insulation to all the heated and electronic parts, etc. So this wouldn't be applicable to any other machine. You have to do certain kind of things, but the spray coolant itself is a really easy setup. And then coming to the biggest upselling point, I haven't seen a single 3 minutes 20 benchy that looks like this in terms of cooling. I just haven't. And as you saw in the last, 4 hours of content on YouTube, I have tried a lot. So basically for big work envelopes where you have to cool down material fast, this is not the most practical, but the most efficient way. We need to find out about those pillars, but then again, I think this is a matter of parameters. Really think we could dial that in, but I need more seat time on the machine, and foremost, I need more finished benchy prints to have a look at it. I mean, most of them detached at a point where I could draw some results from it, so that's a good point. But then again, have a look at stuff like this here. Don't mind the stringing here, but have a look at those overhangs. These are almost perfect. Don't mind this, but I've seen other prints today where this top surface was completely flat. This could also be a thing of G-code. We have to do some like bridging towers, etc. to find perfect parameters for this. I think we could dial in a 3-minute benchy, no questions asked, of really good quality, do input shaping of the current situation on the air bearing, and yeah, the 3-minute quality benchy would be a thing. In terms of just single point cooling, I think there are better options out there. Maybe it has to be combined with other methods like a needle point that is doing like cooling down those pillars. But in a big picture view, this is the best result in terms of overall cooling. I have no idea if I want to go down that route for our next like big milestones in sub 1 minute benchy printing. But this is surely a strong lead, and we have to address bed adhesion first. Give me all your opinions and ideas about that down in the comment section, what I could build on this machine to have a proper testing setup where I can do back-to-back printing, finding out speeds and feeds and temperatures and pressures, etc., you name it. We have to do that first. I managed to do like 3 complete prints in 2 days of uptime of the machine. That is no good for prototyping, especially fast prototyping. So for me, just throwing this one nozzle at a random point at the print and it suddenly is working, that was kind of a surprise. But hey, you got that sometimes. Sometimes you just get lucky on your estimates. And then, maybe lastly, I'm sorry I teased ethanol at the very beginning because I was contemplating to. If you've stuck to the end of the video just to see me like combust in a big ball of fire, I don't have that in me for now. Maybe we should do that at some point, but then we have to take a lot of safety precautions I don't have that right now. Best would be to have that set outside. But then again, with the water spray working so good, I don't really see the up point. I mean, ethanol is, in terms of evaporation temperature, the better material. Also, it should leave a lot less mess on the machine. But then again, if water works, why should we go into an even more outrageous solution? Sorry, I maybe honeypotted you again, but yeah, this is not my intention here, I guess you know that. So, if you want to help me in some way or the other, type down a comment somewhere giving me your ideas, what you've seen out of the slow motion footage, etc. It's just my two eyes doing all of this, and I haven't had a proper look at all this slow motion footage. I'll do that once I'm editing the video. Maybe leave a like, maybe consider subscribing, something like that. It totally helps the channel. And yeah, my name is Jan. I build stuff so you don't have to. See you in the next episode. Bye. Thank you.